Okay, we're looking at related rate problems. We have the radius r of a circle is increasing at 10 centimeters per second. What is the rate of change of the circumference when r is equal to 7 centimeters? And then we got another part to the problem here. It says find the rate of change of the radius, that would be dr over dt, when the rate of change of the circumference, which is dc over dt, is pi centimeters per second, and the circumference is 3 pi centimeters. So we got two different problems just like in the last problem here, all into one. But let's look at the first one again. The radius r of a circle is increasing, so this is dr over dt is 10 centimeters per second. What is the rate of change of the circumference, which is going to be dc over dt when r is equal to 7? So we're just plugging some numbers in. Now here is the relationship of the circumference and the radius, and see anything fishy here? Well, in the previous problems we were talking about the area, and if you took the derivative of the area, remember area was pi r squared, and if you took the derivative of the area, you got 2 pi r. Coincidence? Anyway, so it looks like the derivative of the area happens to, dA over dr happens to be the formula for finding the circumference. And that also works with spheres. Anyway, so let's get started. So here it is, and what we're going to do now is take the derivative of this with respect to t. Right, so we got dc over dt is equal to, taking the derivative of 2 pi r, you just get 2 pi, and then remember we tack on a dr over dt out here. And then we just go ahead, plug in everything that they gave us. Well, dr over dt was 10, and we got the 2 pi, so dc over dt is going to end up being 20 pi. But remember, we don't want to forget our units, and so we say 20 pi centimeters per second. And of course, that's the exact value. You could punch that into a calculator and get some approximated value if you wish. Now let's look at the second part to that problem. It says find the rate of change of the radius, so dr over dt, when the rate of change of the circumference is pi centimeters per second, and then of course we're given this right here, what the circumference is. Right, so we start with the formula here for finding circumference. We take the derivative of this, and they gave us, what did they give us? They, forgot even what they gave us. But anyway, they gave us what the circumference, remember, was, and it was 3 pi, and we needed to solve for r. So we got to find what r is, or do we? Now let's go back up here. Remember, we take the derivative of this, the r just kind of disappears, right? So you're just left with 2 pi and then dr over dt and dc over dt. And well, we don't really need to know what r is, right? Because r doesn't really even play a role in this at all. So that was kind of some extraneous information that we actually needed. So be careful on that kind of stuff. Right? But we're back down to here. Now this was, remember, the dc over dt was 2 pi, and then the dr over dt is what we needed to solve for. And so we end up getting 1 centimeter per second again. Well, we've gotten a lot of these 1 centimeter per second things, but anyway, that's what they were asking. So 1 centimeter per second.